So this next section, section 3 of chapter 11, deals with angles that are called inscribed angles. But let's begin with just a quick refresher from section 2. In section 2, remember we learned that a central angle is an angle that has its center at the, or has its vertex rather, at the center of the circle. So a central angle right here, recall, was equal to the measure of the arc that it intercepts. Now, when we're going to talk about inscribed angles in this section, and an inscribed angle is an angle that has its vertex on the circle itself. Now, this angle is further from the intercepted arc, so this angle is only half of the intercepted arc. So an inscribed angle is an angle that has its vertex on the circle itself. See, the vertex would be right here. And it's further away from the arc, so it's only half the intercepted arc. And that's what this is telling us right here. Let's take a look at a few example problems of inscribed angles. So here we have angle T. Angle T would be this angle right here. And the arc that's associated with it, the intercepted arc, would be 48. So we know the measure of angle T will be equal to half of 48 degrees. So the measure of angle T will be equal to 24 degrees. Now, in a contrast to that, if you look at arc QR is this arc right here. Now, if we're looking for that arc right there, what we could do first is we could find the arc from Q to T. The arc from Q to T would be associated with that inscribed angle 50. So that arc is going to be 2 times that angle. So this arc is 100 degrees. And then because TR is a diameter, we know that if we add 100 plus the arc we're looking for, QR, we'll get a semicircle, 180. So we find out that our arc that we're looking for, QR, would be 80 degrees. So if you are given the angle and you want to go to the arc, you multiply by 2. If you're given the arc and you want to go to the angle, you multiply by 1/2. So the arc is twice as big as the inscribed angle, or the angle is half as big as the intercepted arc. Let's take a look at a few more examples. Example 2. We're trying to find the measure of arc RS. So arc RS would be this one. The inscribed angle associated with it would be this one. So the measure of arc R to S is going to be 2 times 31. The measure of arc RS would be 62 degrees. Now the next question is, what's the measure of angle STR? Well, if I look at angle STR, that intercepts the exact same arc. That intercepts the yellow arc. So if this arc is 62 degrees, the measure of angle STR is going to be half of 62. So the measure of angle STR would be 31 degrees. And then it says, what do we notice about the angles STR and RUS? Since they both intercepted the same arc, we know that angle STR ended up being congruent to angle RUS. in the same circle, if two inscribed angles intercept the same arc, then they have to be congruent angles, because each angle is half of the intercepted arc. Let's take a look at a third example. Here's the theorem that specifically says what we just discovered. Two inscribed angles of the same circle intercept the same arc, then the angles are congruent. So in example 3, it just asks us to name two pairs of congruent angles. Well, first of all, this arc right here, arc MJ, actually has this inscribed angle associated with it, and it has this inscribed angle associated with it. So that means that I would know that angle JLM is congruent to angle JKM. It did ask us to name two pairs of congruent angles. Well, if I was to consider the arc on the other side of the circle, the arc KL, I could get another pair of angles. That would be angle LJK would have to be congruent to angle KML. And there's my second pair of angles. And once again, that's because both of those pairs have the same intercepted arc. Okay, here we have some practice problems. So the first thing you should ask yourself is, in A, are we looking for an arc or an angle? Well, we're looking for an angle. But we can see that we have the arc. So that means the measure of the angle, HGF, is half of that intercepted arc. So the measure of angle HGF would be 45 degrees. In B, well, in B, you can see that we're looking for an arc. So the measure of the arc, T to V, will be equal to 2 times the measure of angle TUV. The arc is twice as big as the inscribed angle. So the measure of arc TV will be 2 times 38. The measure of arc TV would be 76. Now, in this last one on this problem, in part C, it looks like we're looking for an angle again. But the angle that we're looking for has this intercepted arc. And that's the same intercepted arc as the 72. So that means these two angles have to be congruent. So there's really no work for me to do. Angle ZXW is going to have to be 72 degrees. Two inscribed angles with the same intercepted arc have to be congruent to each other. The last thing we're going to talk about is inscribed polygons. An inscribed polygon is a polygon that's inside the circle and all of its vertices are on the circle itself. The circle that goes around the outside is sometimes called a circumscribed circle. That means it goes around the outside. But we're going to be more interested in the polygon. Now, if that polygon happens to be a right triangle, then one of its sides is going to be the diameter, and that side's going to be the hypotenuse. And that's because this is going to be a semicircle here, since we have a diameter, and that means that we have a right angle right here. So if you have a triangle inscribed in a circle, and one of the sides happens to be a diameter, then it's always going to be a right triangle. And the diameter will be the hypotenuse, And the angle across from that, of course, would then be the right angle. So in an inscribed triangle, if one side's a diameter, then it's a right triangle. And the angle across from that side is always a right angle. The other polygon that we're going to talk about being inscribed is a quadrilateral. If you have an inscribed quadrilateral, 4 sides, then the opposite angles are supplementary. Supplementary means that they add up to 180. And that's because the two arcs combined for the opposite angles will give you the full circle. So if I was talking about the angle FED, the arc for angle FED is this one, and that angle is going to be half of the yellow arc. The angle across from that is angle FGD, and the arc associated with that one would be this arc. You can see the yellow arc and the blue arc together give you a full circle, and since each angle is half of its intercepted arc, together they're half of a full circle, so they're 180 degrees. Opposite angles of an inscribed quadrilateral are supplementary. Let's see how that shows up in our problems. So in problem 4A, we have an inscribed quadrilateral. And that means that the opposite angles here are going to be supplementary. 80 plus x equals 180. So x would be 100. Similarly, the 75 and the y are opposite angles in an inscribed quadrilateral. So the 75 plus y has to add up to 180. So y would be 105 degrees. If we look at part B is also an inscribed quadrilateral. So these two are opposite angles. 2a plus 2a equals 180. That would be 4a equals 180. So a would be 45 degrees. And finally, the b's. The 4b and the 2b are opposite angles in an inscribed quadrilateral. So the 4b plus the 2b equals 180. So 6b equals 180. So b would be 30. So in an inscribed quadrilateral, the opposite angles are supplementary, meaning they add up to 180. One more set of practice problems on this type. So if you look at A, we have an inscribed quadrilateral. That means the opposite angles are supplementary. So that would mean the x plus the 82 equals 180. Subtracting the 82, x would come out to be 98. And similarly, the 68 and the y are opposite angles. So y plus 68 equals 180. So the y would equal 112. One more practice problem with a little bit more complication to it. So we have an inscribed quadrilateral. The x's are pretty straightforward. So the opposite angles, 10x plus 8x equals 180. 18x equals 180. X would be 10. For the other one, for the c, we have a c and a 2c minus 6. So the c plus the 2c minus 6 equals 180. They're supplementary. 3c minus 6 equals 180. 3c equals 186. C equals 32. And that's all there is in this section. So to recap, an inscribed angle is an angle that has its vertex on the circle itself. The measure of an inscribed angle is equal to half of the intercepted arc. So if you know the arc and you want to find the angle and it's inscribed, you take half the arc. If you know the inscribed angle and you want to find the arc, you multiply it by 2. If you have an inscribed triangle in a circle, a triangle drawn in a circle where all the vertices are on the circle, and one side happens to be a diameter, then the angle across from that side in the triangle will be a right angle. And finally, if you have an inscribed quadrilateral, a four-sided figure, then the opposite angles have to be supplementary. They have to add up to 180. Hopefully this made sense. Make sure you do the practice.